Hello and welcome to this second video of the first week of Meteorology 107, where we'll be getting into actual course content. Right now, just at a very high-level overview to get you an idea of what is severe and hazardous weather and what kind of things we'll be talking about in this course. If we want to take that phrase, severe and hazardous weather, and break it down, get definition to start out, of course it's weather. And that refers to state of the atmosphere at a given point in time and in place. A very typical thing to contrast weather with is climate. Climate refers instead to state of the atmosphere at a given place, but over a long period of time, the average weather, if you will. Typical example, you refer to weather and saying things, it's 55 degrees and partly cloudy in Ames, Iowa. If I were to say Ames is a cold place to live, I don't really think that. I'm from Minnesota. It's actually pretty nice here. If you were to say it's a cold place to live, that's more of a climate assessment compared to saying temperature, is it raining, what the cloud cover is, all weather assessments instead. Hazardous, fairly self-explanatory. It presents a hazard to people and property. Weather isn't always nice and sunny or partly cloudy or just gentle rain. Sometimes it does damage to people and their property. Severe, sometimes it's just a generic reference to intensity, a particularly strong storm. But it does have a technical definition when it comes to thunderstorms specifically. We'll get into that later in the course. You don't really have to worry about it now. But know that severe does have some official terminology to it as well. Another thing to keep in mind is not all natural disasters fall under this severe and hazardous weather umbrella. In fact, severe and hazardous weather really can be considered a subset of natural disasters. So some earth science related natural disasters that we won't be focusing on in this course because they aren't weather include geologic hazards, volcanic eruptions, earthquakes, avalanches, and landslides, even though this last item sometimes is affected by the underlying weather conditions that have contributed to snow or land conditions in the area. We also won't be talking about hydrologic hazards like tsunamis, big surges of water in the ocean caused by earthquakes. That they do a lot of damage and they're very important natural disasters to consider, but they aren't weather, so we won't be focusing on them in this course. There's also wildfires, which you sort of saw a satellite image of some of the recent wildfires out here along the Front Range in Colorado and Wyoming. I wish it would loop, but it doesn't. Wildfires are sort of an interesting place with this. They aren't weather in and of themselves. A fire isn't weather. But almost everything that goes into the behavior of a wildfire is controlled by the weather. So a lot of your fire weather forecasting is handled by a particular specialty of meteorologists. So they do sort of fall under the umbrella as well. In fact, fire weather forecasting in the U.S. is done by the Storm Prediction Center, the same place that issues all of the severe thunderstorm tornado watches that you see. So it is a very close connection. That being said, we won't be focusing on wildfires in this course, in favor of some of the examples we'll talk about now. Starting out, we have temperature extremes, where we do damage, where people are hurt or tragically experience loss of life due to temperature conditions that are outside of what is healthy. It comes in both on the high end with heat waves where you have extended periods of abnormally hot weather. Sometimes also humidity will contribute to this because we cool through evaporation. And when it's humid, we're less able to do that. These can cause a very high number of fatalities in vulnerable and exposed populations due to heat strokes, or also referred to as hyperthermia. These, as we'll get to later, actually contribute to some of the most number of deaths due to severe and hazardous weather. Cold waves on the other side, or sometimes you refer to them as cold snaps or cold spells. These are on the other side, where you have abnormally cold or windy, sort of contrasting to heat index type of impacts where humidity makes it harder to cool off, so it feels hotter. Wind chill, on the other hand, cools off the skin more readily, so it feels colder. And it makes it more easy to cause frostbite, which is acute damage to the skin, or hypothermia, which is general loss and inability to maintain a high enough body temperature. We also will be talking about winter storms, and these come in many different varieties, as seen here. You just have your generic snowstorms, where you have large occurrences of snow. Squalls, particular type of that has some interesting meteorology to it. Lake effect snow, if you're from any of the Great Lakes regions around the U.S., you're well acquainted with this. We'll talk about that a little bit more detail there. Blizzards are less about the amount of snow that falls and more about the amount that's blowing around. So you can have blizzards without having a snowstorm going over. You just need to have lots of wind causing extended loss of visibility. You also have ice storms, when the precipitation doesn't fall frozen right away, but it becomes frozen on contact with surfaces. And this does a lot of property damage to trees and to power lines and sometimes to vehicles and other things. And sometimes these winter storms, these systems, will bring extreme cold with them, so we have to consider that under this heading as well. Another example that we'll go into, and this is actually the first one we'll talk about once the section comes up, is drought. And this really just refers to a period of abnormally dry weather. And there's a big sliding scale of drought impacts. In Iowa, since we're very agriculture heavy, drought is a serious concern here. And in fact, if you look right now, our current drought monitor in Iowa puts us under the lowest level of drought, moderate drought. But there are some parts of Iowa up into severe drought, and elsewhere in the country there are occurrences of extreme and exceptional drought as well. And this tends to do a lot of agricultural damage. Less so loss to human life unless it comes with heat waves, but it's still very important to consider under severe and hazardous weather. Here, our next item is thunderstorms. This is what a lot of people like talking about. It's one of the more exciting varieties, and it's something we see a lot in Iowa, and it impacts a lot of people. If you were around early this semester at all, in early to mid-August, you're here for the big derecho that came through. That falls under this heading. That's a particularly severe type of thunderstorm complex. And so with severe thunderstorms, you get hazards like severe wind, you get hail, you can get tornadoes, you can get lightning and flash flooding. There's a lot of things that happen with this, and the things that lead to thunderstorms are very meteorologically interesting. So we'll be getting into all of that later in the course. We actually have a whole week and a half set aside for severe thunderstorms and some of their hazards that come with them. Another very meteorologically interesting and complex are tropical cyclones. These, if you're from the U.S., these are typically referred to as hurricanes if they're high wind, that's above 74 miles an hour, or tropical storms. As an example, actually right now, I just pulled up this from a particular satellite expert on Twitter. This is of now Hurricane Delta forming in the Atlantic. Expected to have impact over this coming week in the Gulf of Mexico area. In some ocean basins, this typhoon is in the eastern Pacific basin, or in the western Pacific on the other side. They're referred to as typhoons once they reach high intensity. Cyclonic storm in the Indian Ocean. They come with a variety of hazards. Again, wind, that's primarily how they're assessed on the category scale. We'll go into all those details later. But wind isn't their only hazard, and there's a lot of discussion about, is it actually right to categorize these according to just wind? Because storm surge plays a big role in the amount of damage that it has, along with flooding, not just from storm surge, the ocean level being pushed up and rising inland into the basins there, but also just flooding from the amount of water that these systems can drop. And they can even come with tornadoes and other severe thunderstorm type hazards in their bands, because that's what these are. They're organized systems of storms, of convection. Another example is sort of referred to in the past sections because flash flooding is a particular type of flooding that often comes with the previously mentioned thunderstorms and tropical cyclones. But there's other types of flooding as well that fall under severe and hazardous weather. We get lots of types of river flooding. This can be just due in the spring when you have frozen precipitation melting, often accompanied by different ice jams or log jams, things that block the ready flow of water out of a river basin, as well as precipitation over a wide enough area, just dumping enough water that can't be emptied out of the basin in a fast enough time to prevent it going above where water levels should be. There's also other non-meteorological causes. We won't be going into any of those and talking about dam failures or anything like that, but know that there is flooding that can occur that isn't strictly caused by severe and hazardous weather. It brings us to sort of why do we care, what the societal impacts are. Hopefully you taking this class, being interested in taking this class, know that we care because weather impacts people and their property. NOAA has this really great website, really informative website, $1 Billion Weather and Climate Disasters. I'll have the link in a later slide and in the description and on Canvas, but we focus, or at least NOAA focuses on these disasters because they have the largest impact. There have been 263 of these $1 billion threshold weather climate disasters. I think they say climate disasters, so it includes things like wildfires. And they total almost $1.8 billion in damages and over 14,000 lives that were directly caused from these disasters. And that isn't even including things like heat waves or particularly severe hurricanes, or where you have indirect fatalities and loss of life due to the circumstances that surround them. They aren't just directly caused from disaster itself. And it's important to note that these events have been increasing in number and amount of damages in recent years due to population spread. More people are being exposed to these things, and they're in more vulnerable areas. There's larger places of populations in Tornado Alley, where more severe weather and tornadoes can hit, more people along the coasts where hurricanes can impact. And some of these things are influenced in severity by climate change as well. Things are getting more intense or more likely to occur. And that brings us to some of the summaries. I just want to bring these statistics up from this website, just sort of getting an idea of what tends to cause the most deaths and cause the most property damage. This is a list of the most deadly U.S. events. Again, these are direct fatalities, not including indirect effects, which heat waves tend to have a lot of. Again, the most top ones are Hurricane Maria and Hurricane Katrina. If you've been around, you've likely heard about those in the news, either in the recent past and a little bit more distant past. But these have caused a lot of loss of life. Next coming up are, again, I've been stressing this before, heat waves tend to cause a lot of fatalities, regretfully. And then after that, we get a little bit more of a mix of other hazards that come up. We have tornado outbreaks, blizzards, and flooding also can contribute to loss of life. If we look at costs of disasters, hurricanes top the list here because of their combination of their severity that comes from both wind damage, just things being blown over and directly damaged, and flooding. There's a lot of storm surge and rain-related flooding that comes with these particularly severe tropical cyclones. But again, you can also get loss from droughts and just other forms of flooding as well. So that sort of sums up the types of hazards we'll be looking at in this class, and we'll be going into a lot more detail on each of these once we get to sort of the focused section of this class on the severe weather hazards once we get to week 4. But before then, we want to establish a good background so we can actually understand what's going on in detail about all these hazards and what meteorologically contributes to them. So we have to get a little bit of meteorological introduction in first. That starts right away with the next video this week with properties of the atmosphere, talking about things like pressure and temperature and how they behave and relate to each other, especially moisture, which drives a lot of the things we see in the atmosphere. Videos 3 and 4, part 1 and part 2, are going to be coming in on that in the next 2 days. I also want to let you know that quiz 1, this first week's quiz, is going to be posted along with this video up on Canvas. If you wanted to play it safe, wait to do this quiz until after videos 3 and 4 come out so you know all those details. But if you're a meteorology major, you already have studied this stuff, or you're really quick on your Google searching and you want to have references up while you're taking this quiz, again, it's time limited, so should rely on knowledge that you already have rather than having to look it up from your notes during the quiz. But I'm not going to stop you from using them if you need it. Again, your decision on when you want to take the quiz. And then, reminder from last time, discussion post is up, due on Saturday. Survey, again, not required to fill out the survey. I just appreciate it to help establish a place for informal discussions and for office hours. That needs to be in, if you want to fill it out, by Wednesday at noon, so I can then respond and start up office hours on Thursday, which hopefully you'll be hearing about in a Canvas announcement at that time. Again, thank you for tuning in, and you'll be hearing from me next in part 1 of Properties of the Atmosphere in the next video. Thank you.